Hi everyone, welcome back to CodeStack Daily. In today's video, we'll tackle an interesting coding problem, design a stack with increment operation. So in this, we have to do a lot of things. Here we have four different functions, like we have init, push, pop, and also an increment function. So in this problem, we need to design a custom stack that supports the following operations like push. The basic thing the push does is adds an element to the top of the stack, but only if the stack hasn't reached its maximum size. So the pop function removes and returns the top element. If the stack is empty, we need to return -1. And increment, it increments the bottom k elements of the stack by a given value. So if we see here, we have a custom stack of int max size. It initializes the object with max size, which is the maximum number of elements in the stack. So we also have a void push. It adds x to the top of the stack if the stack has not reached the max size. And we also have the pop method here. It pops and returns the top of the stack or -1 if the stack is empty. Then we also have the increment function here. It increments the bottom k elements of the stack by the value. And if there are less than k elements in the stack, we are going to increment all the elements in the stack, right? So here we have a basic example. Okay, we are having the first, basically we are having uh, custom stack here. Custom stack, um, here it is going to give us the size, and here we are having the two push operations where first we are pushing 1 and then we are pushing 2. So finally we'll have the 1 and 2 in the stack. Then we are having a pop operation. So popping up the stack will have 2 gets deleted from the stack, that means popped out, and we are just going to return 2. Then we do have 3 push operations here. So after we push again 2, we'll have 1 and 2 in the stack. And after we push 3, we'll have 1, 2 and 3. And here we reach the maximum stack of maximum size of the stack. So when we try to push the element 4, we do not push it because the size of the stack already is 3. Then again we are having the increment. When we are going to increment by 500, the stack becomes 101, 102 and 103. Then we are going to increment by 100 again. We are having 201, 202 and 203. Then we are going to pop it. So as we pop, we are going to return the top element, that is 103. Then again the stack becomes 201 and 202. Then again when we pop the stack, the 201, sorry, the 202 is popped out and the stack contains only one element, 201. Again when we pop it, 201 is popped out of the stack and it is returned and the stack becomes empty. So when again the pop is done, we'll return -1 as the stack is empty. Okay, now let's get started by writing the custom stack. So firstly we'll write the init function here. So basically here we are having two parameters, the max size, sorry, one parameter, the max size, that is the int. So I'm just initializing the stack self dot stack a basic or an empty list, and then self dot max size it equals to max size itself. Okay, then we start by defining the init function here, which initializes our stack. We are using an empty list stack to store the elements, and a max size will store the maximum number of elements that our stack can hold. Now let me move to the push function. So here in push function we need to push an element into the stack. So first we are checking if the length of stack, okay, self dot stack is less than self dot max size. Only in that case we can push an element into the stack. Self dot stack that append the element x. Okay, then now we are going to write the code for the pop function. Then again we are checking if the length of self dot stack is 0. It means that there are no elements in the stack. Then we are just returning minus 1, or else we have to return self dot stack dot pop. We just need to write this. Now pop method checks if the stack is empty. If it is, we return minus 1. Otherwise, we pop the top element from the stack and we are then going to return it. Now it's time to write the code for the final method. We need to implement this increment. This C method increment uh, the bottom k elements of the stack by a specified value. If k is greater than the number of elements in the stack, we can increment all the elements. Okay, so let me write take limit equals to minimum min of k and length of self dot stack. So here we can only increment up to the limit value. Okay, then for I in range of limit. Okay, for I in range of limit, self dot stack of I plus equals to value. Okay, we're just incrementing every element with the value. Now let me run the code. Okay, oh, I've done self dot stack. Sorry, self dot stack. Now let me run the code. Okay, the public test case or this example is working perfectly fine. Now let me submit the code and see if that works good or not. Yeah, our code perfectly works, and the custom stack method is perfectly executed, and we have bet 53.14% of users, and the runtime is 91 milliseconds. Okay, so to sum up, this solution uses the three main methods: push, pop, and increment. The time complexity for each operation is very efficient. Both push and pop run in constant time, the order of 1, while increment runs in the order of k, where k is the number of elements to increment. And by keeping our design simple and intuitive, we ensure that the stack performs very well even with the added functionality of incrementing elements. Okay, now thanks for watching, guys. I hope you found this video very helpful. Don't forget to like this video and subscribe to Code Streak Daily for more coding tutorials. If you have any questions, feel free to leave a comment below and I'll be glad and very happy to help. See you in the next video.